Hello everyone. In this video, we will explore the different Amazon EC2 instance families, what they are best suited for, and some real-world examples where they are typically used. Let's begin with general-purpose instances. These provide a balanced mix of compute, memory, and networking resources, making them suitable for a wide variety of workloads. Instances in this family start with M, T, and Mac keywords. M family is a jack of all trades. It's used for applications like business critical servers, backend applications, and enterprise applications such as SAP or Microsoft Exchange. T family, these are burstable performance instances, great for workloads that don't use CPU constantly, like small databases, development, and test environments. Mac is designed for testing and signing Apple applications. This is a startup hosting their web app and MySQL database might use a T3 or M5 instance because it balances cost and performance. Next are compute optimized instances designed for workloads that need high performance processors but not as much memory. Instances these families start with the letter C. Typical use cases include batch processing, high performance computing, scientific modeling, ETL transcoding, and gaming servers. For workloads that require large amounts of memory, AWS offers memory-optimized instances. These are tuned for fast performance on big datasets that need to be processed in memory. Instances, these families start with R, X, Z, and U. R family is ideal for memory-intensive applications like high-performance databases in memory caching and big data processing. X offers extremely high memory per virtual CPU, often used in SAP HANA deployments or other in-memory databases. Z provides both high memory and high CPU frequency, suitable for electronic design, automation, and certain financial analytics. U is for bare metal instances with terabytes of memory, used for the largest enterprise-grade in-memory workloads. Then we have storage optimized instances. These are designed for workloads that need high sequential read and write access to very large datasets stored locally. Instances, these families start with T, H, and I. I optimized for low latency, high transaction workloads such as high frequency trading, NoSQL databases, OLTP systems. D suited for dense storage workloads like big data analytics, Hadoop clusters. H optimized for high disk throughput, often using distributed file systems or data warehousing. Accelerated computing, some workloads need specialized hardware. That's where accelerated computing instances comes in. Instances, these families start with PL, G, INF, P, TRN, and VT families. P family GPU powered for deep learning training scientific simulations. G for optimized for graphics intensive workloads such as 3D rendering, virtual workstations. INF for high performance machine learning inference using AWS Inferentia chips, cost efficient and scale. And TRN family designed for large scale ML model training. Finally, we have high performance computing instances. These are designed for the most demanding and complex computational workloads where performance, networking, and scalability are critical. Instances in this family start with HPC6 and HPC7. Common use cases include scientific simulations, weather modeling, seismic processing, genomics, rendering, and financial risk modeling. I'll explain the EC2 naming convention for instances. This is important because the name of an instance typical type actually tells you a lot about its purpose, performance, and hardware. Let's start with the series code shown on the left-hand side of the slide. This tells you the main purpose of the instance family. Instances that start with M, T, or Mac are general purpose. C for compute optimized. Instances that start with R, X, Z, or U are memory focused. When you see D, I, IM, or IS, think storage. If the code starts with G, P, INF, TRM, T, or F, it's an accelerated instance. Now let's look at the options or modifiers shown on the right-hand side of the slide. These letters are suffixes give additional details about the hardware inside an instance. The letters A, G, and I indicate which processor the instance is using. A for AMD, G for AWS graphical processors, and I for Intel. B, D, and E are tied to storage families. B for block storage optimization, D for local instance store volumes, E for extra storage memory, N for network and EBS optimized, and Z for high CPU frequency. M1 Ultra, M2, and M2 Pro are Apple-based chip modifiers. So by combining the series code with these modifiers, you can tell both the family purpose and the special hardware characteristics of an EC2 instance. Now that we know the codes, let's look at how these families align with the most important architectural design choice, the memory to vCPU ratio. This table is organized by the ratio from 2 to 1, 2 GB of RAM per virtual CPU, all the way up to 32 ratio 1 and higher. This ratio is what determines if your application is CPU bound or memory bound. The compute series sits at a low ratio, typically 2 to 1 like C5N, meaning the focus is on raw processing power, not high RAM per core. If your workload is pure crunching, this is where you start. The general purpose series sits firmly in the 4 to 1 ratio, a good balance for most standard enterprise applications. Notice the storage ID and H series are also generally at 4 ratio 1 or 8 ratio 1. For example, the i3EN is at 4 ratio 1, balancing cores with enough memory to manage its dense local storage. When you see ratios of 8 ratio 1 and higher, you are squarely in memory optimized territory. The R and X series are here, peaking with the X1 and XCE at up to 30.5 ratio. These are designed for massive in-memory databases, large data analysis, or processing that requires keeping entire datasets in RAM. Accelerated instances are scattered as the primary metric is the GPU or chip performance, not just the memory ratio, but they still need RAM to feed these accelerators. P5 and P6 series are unique with different memory ratios depending on the specific model and accelerator used. When selecting an instance, always cross-reference the family code from the first slide with the appropriate ratio on this slide. For example, if you need a memory-intensive data warehouse, you had to start with an R or X series instance to ensure you have that high memory to vCPU ratio. This slide shows complete anatomy of an AWS EC2 instance name. Every part of this name is a crucial piece of information that helps you understand the hardware's capabilities and cost. The entire string is the instance type, the C7GN.2x large, and it's broken into two main sections, the instance family before the dot and the instance size after the dot. C7GN, the family portion, is the core of the name, detailing the hardware configuration. The letter C defines the series or family. In this case, C stands for compute optimized. The next digit 7 indicates the generation of the instance. A higher number means newer hardware, better performance, and usually better efficiency. The following letters GN are the options or modifiers that specify special features. G means it uses AWS graphical processor. N means that it has enhanced networking and is EPS optimized. This portion 2x large determines the scale of the resources you get, the exact number of vCPU, and the amount of memory. Now let's see how to calculate the actual resources for this instance using the size suffix. The calculation starts by defining the base unit large, which typically represent 2 virtual CPUs. The suffix x large means multiply the base vCPU count by powers of 2. For x large, you multiply by 2 into 2 is equal to 4. Therefore, the total vCPU count is 2 into 4 is equal to 8. Finally, we determine the memory using the family's known ratio. As a C compute instance, its memory to vCPU ratio is 2 ratio 1. This means for 8 virtual CPUs, the total memory is 2 GB per virtual CPU into 8 virtual CPUs is equal to 16 GB. So by simply reading the name C7GN.2x large, instantly know you are getting a 7th generation Graviton powered network optimized 8 vCPU instance with 16 GB of memory optimized for compute intensive task. While the naming convention and the memory to vCPU ratio rules we discussed are great starting points, there are several key exceptions and specialized instance types you need to know about. Starting with the Mac instance, these are unique because they use Apple hardware and are presented as bare metal. Notice the non-standard vCPU and memory configurations. For instance, the Mac1.metal and the new Mac2 M2 Pro.metal give you 32 GB of memory and 12 vCPUs. This don't conform to the simple 4 to 1 memory ratio seen in other general purpose families. The T series or boostable performance instances are exceptions to the memory ratio. The smaller sizes T2, T3, and T4G Nano, Micro, and Small all have 1 or 2 vCPUs, but which are higher than 4 to 1 memory ratio in the smallest sizes. A green box, the U series or high memory instances are built to run large single node in-memory databases like SAP and Oracle. Their memory to vCPU ratios are extremely high, often 32 to 1 or even higher. The X and XC instances are also memory focused, specifically for databases and big processing. Finally, we have exceptions defined by a low memory to vCPU ratio or the specific hardware. The C5 answer is an example of a compute-intensive exception, offering an aggressive ratio like 2.625 to 1 to maximize CPU power relative to RAM or network-intensive jobs. The GPU-accelerated P series also have their own ratios, which are often lower than general-purpose types because the majority of the compute resides in the dedicated GPU memory, not the system RAM. In summary, when selecting instances for Mac workloads, in-memory databases, or highly specialized compute like GPUs, always consult the specific documentation and their hardware configuration, deliberately break the standard naming conventions. Thanks for watching. Understanding these exceptions is key to mastering EC2. If you have any questions, drop them in the comments below. Don't forget to click the notification bell so you don't miss out. Stay tuned for more AWS concept videos. Thank you.